Alright, we're switching gears and moving on to Chapter 5. And in Chapter 5, we're going to talk about inequalities instead of equations. So by the end of this lesson, you should be able to solve linear inequalities with addition and then solve them with subtraction. So before we get to solving, we got to talk about what inequalities are. So remember, equations have an equal sign, where inequalities are not exactly equal, but they're still related. We have several symbols here, and you need to be able to tell the difference between them. So remember, we read things left to right. When you have a symbol that opens up like this, it is a greater than symbol. It is saying that whatever I put in front of it, x is greater than 3 or 2 or whatever. Where this guy here is a less than symbol. Now, I know back in the day you guys always learned like the alligator eats the bigger number, so you'd put it this way. But remember to read this out loud. We would say 3 is less than 4. Or you could read it this way and say that 4 is greater than 3. And then if we put an equal sign underneath it, remember that means greater than or equal to. It's giving us one more option. So this one is less than or equal to. So now that we have the vocab out of the way, the weird thing about inequalities is they have infinitely many solutions. So remember when we solved equations, they only had one solution. We'd get something like x equals 2, and that was saying that was the only value that x could be. But now we're going to get things like x is greater than 2, which means that we want to include every single number on this planet that's greater than 2. So in order to represent that, we graph inequality solutions. And hopefully you remember this from other classes, but if not, this table is a nice little thing to wrap your mind around. So like we said, we had those 4 symbols back there. We show the greater than and the less than symbols by using an open circle. And when it's equal to, we close in the circle. So this one here, x is less than 3. We would put an open circle on 3. Because x cannot equal 3, but it goes right up to it. And then, because we want all the numbers smaller than 3, think about on a number line where those numbers are. They'd be everywhere to the left. So this graph shows us where all of those solutions are. Where if we have one like m is greater than or equal to -2, it could equal to, so that's why we fill it in. And then all the numbers that are bigger than -2 are to the right. Make sure you're careful when the letter's on the wrong side like this one. Always start at the letter and read it. We want all the values that are less than or equal to -1. So because they can equal, again, we're going to close it in, and everything less than -1 is to the left. We're also going to try something else in this class, so we're going to write our answers in interval notation. Interval notation talks about the span that our answers can be in. So if I give you something like x is less than or equal to 2, you could write the actual graph out. We'd close the dot, just like we did before, and all the numbers less than 2 are this way. So think about on a number line what that means. Every single number over here until forever, until the smallest number you can think of and then some, so to -infinity. So the interval notation of this means exactly the same thing, would say that we are going from -infinity up until 2. Now, just like we had open dots and closed dots, we're going to use parentheses and brackets for interval notation. So brackets are what we used for closed dots, and remember that's when it has the equal sign underneath. And we use parentheses when we have open dots, so no equal sign underneath. So if I give you a number like this, x is greater than -1. Think about it on a number line, and remember we always read things left to right. So the first time we talk about this as we're reading is when we're at -1, and because it doesn't equal -1, we're going to put a parenthesis around it, And then it goes on to positive infinity forever and ever and ever. Infinity should always have a parenthesis around it because you can't ever equal infinity. And if we were to draw a bracket around it, that would imply that we equal infinity. And infinity is not really a number. It's just a symbol that stands for the biggest number you can think of. So let's actually try some solving. So just like we had properties of equations, we have properties of inequalities. And basically these say that as long as you add something to one side, you have to add something to the other side. So if you have this, and you add C here, you have to add C to keep this a true statement. Doesn't matter if it's greater than symbol or less than symbol, whatever you do to one side, you have to do to the other. And the same thing works for subtraction. As long as you subtract the same thing on both sides, you're fine. So let's solve. We're going to solve them, we're going to graph them, and we're going to write it in interval notation. So 3 things: solve, graph, interval notation. So the first one, we're trying to get m by itself. So let's add 8 to both sides. So we end up with 30 over here is greater than m. Now you can flip this around. I always like to flip it around, but remember that you want the alligator eating the 30, if you want to think about it that way. So we want all the m's that are less than 30. So when we go to graph this, 0 down here, we got 30 here. We do not want to equal 30, but we want to get really close. So I'm going to leave an open circle on 30, and all the numbers less than 30 are this way. So there's my graph. Now, interval notation, it's helpful to look at it in a graph format. This is going to negative infinity. So remember when we read things from left to right, interval notation says we're going to start at negative infinity, and then it's going to go up to 30, but it's not going to equal 30. So we'll have parentheses around it. So all 3 of these representations here show us where our solutions are. This one says that it's all the numbers less than 30. This one shows us on a graph where those solutions are. And this one gives us an interval. It's between negative infinity and 30. Let's do 1D down here. So remember our goal, we're trying to get m alone again. So because there's a plus 19, I'm going to subtract 19 from both sides. So we get m is greater than 37. And now that this is done, we can graph it. We have 0, we have 37. It doesn't matter what other numbers you put on there. I like to put 0 for reference and then whatever number you're graphing. And just like before, this is just a greater than symbol, so I'm going to make an open dot. And all the numbers bigger than 37 go this way. So I have an inequality, I have a graph, I need to write this in interval notation. So remember we read it left to right, and the first number we come across is 37, but it can't equal 37, so I have parentheses. And this arrow points to positive infinity. So all 3 of those representations tell us where our solutions can be. Let's try some more that require a little more work. So when you look at these ones here, first thing you notice is you got numbers on one side and letters on 2 sides. So we got to consolidate our letters. So let's subtract 9n from both sides. So when that happens, I get negative 1 is less than n, and I'm done. So I'm going to rewrite this to n is greater than negative 1, and then I'm going to graph it, and then I'm going to write it in interval notation. So my graph, I have an open circle at negative 1, and I want all the numbers bigger, so I'm going to go this way. And then when I read this, I start at negative 1, and I go to infinity. Let's try this next one. Same setup in the beginning. My number is going to stay over here. I'm just going to subtract 4h from both sides. So I get h is less than or equal to 12. So there's one way to represent my answer. Now I'm going to represent it with a graph. That was the first one we've done with a closed circle, so pay attention to that. We can include 12, and then all the numbers less than that are going to be this way. So remember, when you write interval notation, you read it left to right, and these answers start way down at negative infinity, and they go up to 12. But remember, because we have a closed-in circle, and because it's a less than or equal to, we write a bracket around there, meaning that it can equal 12. So we, of course, have a story problem in here. So remember when we learned about the plus sign? Let's go back. Plus sign. We used words like some or more than. And then when we learned subtraction, it was difference, and on and on. We have symbols for these inequalities as well. Less than or fewer than for the less than symbol. The greater than symbol, we tend to use that or more than. These ones are really the ones you need to pay attention to. At most refers to less than or equal to, no more than, and then obviously less than or equal to. This one is at least, no less than, or greater than or equal to. Now I know those seem backwards, but when we do a problem, hopefully it'll make a little more sense. Felipe needs for the temperature of his leopard gecko's basking spot to be at least 82 degrees. So stop and think about that. If you want something to be at least 82 degrees, would you be happy with 81? Hopefully you said no to that. That's not warm enough. Would you be happy with exactly 82? Yes, that works. How about 83? That also works. So when I say at least, I want every number greater than or equal to 82. So that's why at least means greater than. Currently, the basking spot is 62.5 degrees. How much warmer does it need to be? So we're at 62.5 degrees. We need to add a certain amount of temperature and get it at least 82 degrees. So then this is a pretty easy equation to solve. We're just going to subtract the 62.5 from both sides. And we end up with x has to be greater than or equal to 19.5 degrees. Which means in this problem that we need to get it up 19.5 degrees or more, because we're okay with it being warmer than 82 degrees. So try some on your own. I left you these two problems here, but then there's also these ones back here that we didn't get to. So you got 4 problems you can do on your own. Make sure that you solve them, graph them, and write them in interval notation. Make sure you write down any questions you have, and we can go over them on Monday. Enjoy your weekend.